Okay, thank you so much. Okay, good afternoon, everyone, and welcome to this presentation. Today, we are looking at fostering communication in the mathematics classroom. Before we can begin our discussion on this important topic, I'm going to look at why communication is so important in mathematics, the benefits of communication, types of communication that exist within the mathematics classroom, and what is being communicated in our mathematics classroom. Then we will examine the issues of how to foster effective communication in mathematics. So we'll begin. Why communication in mathematics? In order for our students to develop an adaptive reasoning, they need many opportunities to practice communication in mathematics. Through communication, our students can reflect on their own ideas, engage in refinement, discussions, and amendment of these ideas. When students are challenged to think and reason about mathematics and to communicate the results of their thinking to others, both orally or in writing, they learn to be clear and convincing. Listening to others' explanations gives students opportunities to develop their own understanding. Therefore, we must give our students opportunities in the classroom to engage in a rich discussion. When we give students these opportunities, they're able to share their different perspectives and in turn develop a better understanding. Not only should students be involved in talking and but writing as well. When students engage in writing about mathematics, this can help them to consolidate their thinking. When we write our thoughts, we normally will be required to reflect on our works and clarify our thoughts about the ideas that we are developing. Therefore, we need to give our students the opportunities to test their thoughts and demonstrate their understanding by shared knowledge in the mathematics classroom. So communication is absolutely vital in mathematics. Communication is also a standard in the National Council of Teachers of Mathematics. The NTCM has process standards that serve as catalysts for the continued improvement of mathematics education. One of the standards is communication, which implies that communication should be an integral part of the teaching and learning process. The traditional way of teaching should no longer have a dominant part in our classroom, where the teacher talks only or mostly. If we examine this standard, we will see that communication instructional programs must be geared from pre-kindergarten right to grade 12 to enable each child and every child to communicate effectively. One, when we communicate according to the NTCM, it organizes and consolidates students' mathematical thinking, communicating their mathematical thinking coherently and clearly to peers, teachers, and others. This is an absolute necessity. Analyzing and evaluating the mathematical thinking and the strategies of others is also part of this standard. Using the language of mathematics to express mathematical idea precisely is also another important part of this standard. So we see there are other standards including problem solving, reasoning and proof, connection, and representation. But today, our focus is mainly on communication. What are some of the benefits of communication in the mathematics classroom? Today, we know that our students are referred to as digital native. They spend a lot of time on computer games, digital music, videos, cell phones, as well as the web itself. Being used to constant engagement and multitasking in their day-to-day activities, students need a high level of social and creative engagement in learning. Therefore, traditional teaching approaches that favors passive content consumption is no longer applicable and has to be substituted or at least complemented with high interactive learning processes. So we are going to look now at some of these benefits. There are mainly three benefits that I'm going to highlight here. One, social interaction, building confidence in students, and providing an insight into our students' thinking. The first one, social interaction. This serves as a catalyst of the learning process in mathematics classroom. This argument is well supported by Rothman 2005, who contended that students learn more when they are able to talk to one another and be actively involved. In addition, active engagement in social interaction with other students in the mathematics classroom helps students to take greater responsibility for their own learning as they become the readers, the writers, speakers, listeners, and the thinkers within our classrooms. Another benefit of communication is building self-confidence. Napoleon Hill stated, "Your mental attitude is the only thing over which you and only you have complete control." Self-confidence is a belief in your ability to do your best. You don't have to be the biggest, the best, or the brightest to have self-confidence. But we just have to believe that we are capable of doing our best and we are willing to take that risk. Now, giving students the opportunity to communicate within the classroom is taking that risk. And that risk builds self-confidence. When students are confident about doing mathematics, they dominate the teaching and learning activities within the classroom. Bennett 2004 said, "When students are allowed to engage in meaningful discourse, they recapture the intellectual authority of the classroom that is rightfully theirs to begin with." We have to give the students the opportunity. We have to give them the opportunity to be learners, to be responsible for their own learning within the classroom. When students are responsible for their own learning, they gain confidence and they believe what they are doing is correct. Sarah argued, when students are able to effectively engage in discussion about mathematics, they will be better able to build confidence and see themselves as mathematicians. And that is what we want in the mathematics classroom. Further, Cousins implies that mathematical discourse helps to develop students' confidence, interest, and perseverance. We want students who are confident and who are able to persevere beyond the difficulties. Therefore, we have to ensure that communication is a vital part of our teaching. In addition, mathematics discourse has a potential to empower students in their learning. Every teacher will want their students to be empowered, feel empowered, especially in mathematics. Communication in mathematics provides the teacher with an insight into students' learning. As students express their mathematical ideas, findings, and generalizations, teachers have a great opportunity to listen and get a first-hand view of how students are thinking at the precise moment. We don't have to wait for a test or an assessment to understand how students are thinking. When we make communication an important part of our teaching, we get to know what students are thinking immediately, and we are able to adjust our teaching and address misconceptions. Teachers can identify misconceptions, understandings, mistakes, and errors as students communicate in the classroom. Rowe, Ron et al. 1990 also support this notion when they imply that communication in mathematics assists the teacher in gaining insight into students' thinking so as to guide the direction of instruction. How much more we want? Of course, we would like to know how our students are thinking. Small also support this notion when she coined these words. Communication in mathematics, whether silent self-talk or communication with peers or a teacher, is essential to students as they learn. It is also a critical assessment tool for teachers. Now we might ask, what sort of communication exists within the classroom, especially when we think of mathematics in terms of symbols and all equations and all of that? What sort of communication can really exist within the mathematics classroom? We have student-to-student interaction, we have conferencing, and we also have teacher-to-student interaction. Student-to-student interaction. When students express their thoughts, discussions, and challenging the ideas of others and work together towards a group solution to a given problem, students develop critical thinking skills as well as skills of self-reflection and co-construction of knowledge and meaning. This is the student-to-student interaction we want to see in our classroom. Teaching practices that emphasize student interaction improve both problem solving and conceptual understanding without loss of computational mastery. In addition, benefits increase further when students share their reasoning with one another. We can learn from each other. Students come with different prior knowledge, and when students are given the opportunity to interact with each other, they are benefiting, they are learning from each other. No longer the teacher is seen as the only giver of knowledge. They can gain knowledge from each other, others. The maths classroom functions as a community where thinking, talking, agreeing, and disagreeing are encouraged. So learning is no longer my responsibility only. The responsibility is shared with all the students and teachers. Teacher to student interaction. Teachers who ask students challenging questions and encourage students to explain the evidence behind their statements in classroom discussions enhance the quality of discourse. Teachers' interaction with students vary in quality and have appreciable effects on mathematics achievement outcomes. So no longer we can expect our students to sit and just listen to us. We have to encourage them to also to be part of the learning process because there are great benefits to gain. Teacher-student interaction are a malleable feature of classroom environment and have been the focus of national efforts to raise mathematics achievement. When we interact with our students, we get to know how they are thinking. Therefore, we can change the classroom environment and prevent them from being so frustrated. We can help them at the point of their need at that moment. Then we have student-teacher conferencing. This is very important. What it is all about. Student-teacher conferences are a one-to-one forum that allow both the student and teacher to mutually discuss their concerns, feedbacks, and goals. We know that in our classroom there are some students, they are very shy, withdrawn. So even though we have a rich discussion in the classroom, there are some students who would not voice their opinion. So here, this is very important so that the teacher can hear every child, can reach every child, and can meet the needs of every student in the classroom through student-teacher conferencing. Student conferencing is a great way to get to know students on a more personal level. Every meeting with students is an opportunity for assessment. It's an opportunity to understand students' thinking, errors, misconception. Is an opportunity to clarify issues. Student-teachers conferencing is a powerful strategy that enables teachers to build a relationship with each student, address their needs, state their expectations, and above all, help students to attain their greatest potential and work towards academic excellence. It is very important that we express our expectation to our students. Sometimes students improve, they try to please us as teachers when they know what we expect of them. So this student teachers conferencing provide the opportunity for us to meet every child on a one-to-one basis. So this is important interaction within the classroom. Now, what is being communicated in the mathematics classroom? Surprise. Some students, when they are faced with a problem, they are like, what is this? They are so surprised. That's one of the form of communication we have in the mathematics classroom. How do we deal with that? Another type of communication may be angry, frustrated. I just can't get this out. What is this math all about? So when we allow students to communicate, we get to know all these different emotions that students are expressing within our classrooms. Then some students are clueless as what to do next. They are confused. They don't know what step to take. Then we have some students, the high flyers, they are very happy, love mathematics. Then we have some who are sad because they just cannot figure out this math thing. Furthermore, we have students who are joyful because they are getting the problems correct. And then we have those students who experience an aha moment in the classroom. So all these things are the emotions and feelings that as teachers we get to know when we allow our students to communicate within the maths classroom. And we can also address and transform these feelings from our students because we will get to know that our students are feeling this way when they are able to express these feelings in the classroom. So, what is being communicated in the classroom? The culture and the environment within the maths classroom should be one where students are totally free to communicate respectfully their progress, their feelings and attitudes, and also their frustration, so that as teachers, we can meet them at their need. We can help them when they really need the help. Now we are going to we have looked at the importance of communication, the benefits of communication. We have also looked at some of the feelings, the different forms of communication within the classrooms. Now, our next step is to foster effective communication within the maths classroom. In fostering effective communication, as teachers, we must establish a conducive environment Our instruction should focus on questioning. Questioning that will enable multiple strategies of solving problems, and questioning that will help us to monitor students' progress. We must also have in our classroom open sharing periods for students. Students must have the opportunity to justify their solution and make necessary connection in mathematics. So our first step will be establishing a learning environment that encourages students' participation. This is very important because if students are not comfortable in expressing their feelings, they would not talk. So as teachers from day one, we have to set ground rules and expectations that will support and accept the contribution of every student. Students must know that no question is a foolish question or a stupid question. Every question must be allowed to be aired in the classroom without any laughing or mocking, so that students feel totally free to ask questions. Also, as teachers, our expectation must be that every child can and will learn mathematics. This must be communicated. This environment must be established within the classroom if we are going to have effective communication. Furthermore, the quality of communication that emerges in the mathematics classroom depends on the atmosphere of the classroom and the relationship between peers, the relationship between students and teachers. If the teacher value an environment which supports opinions and positive interaction between individuals, then communication will prevail effectively. Students must feel totally free to express their emotions and ideas to the teachers. Teachers must not have expressions on their face that make students feel what they are saying is foolish. Teachers' attitude towards students' questions and responses in the classroom must be one that encourages them to further elaborate and extend on their ideas, expand on their ideas. The culture of the classroom needs to be one in which students feel totally safe, totally free, and where their contributions are valued. Students must know when they communicate within the classroom, this is a safe place to express my thought. Someone will value it. My teacher will take note of my opinion and my ideas. So we can only have effective communication when the environment is right, when we establish the correct environment within our classroom. In addition to that effective and good environment, discourse-oriented instruction must focus heavily on questioning. We must allow students to question, and we also as teachers must question students to get to know what they're thinking. So we see here that Piccolo et al. They suggest that whys and how questions lead to greater understanding than closed-ending questions. So as teachers, we must ask more why and more how questions to stimulate further communication, further discussions, and different concepts in mathematics. Van der Waal supported this idea when he stated that both procedural and conceptual knowledge are important, and questions must target both. Teachers who are purposeful in their implementation of discourse will be able to target conceptual knowledge by altering how they phrase questions. When teachers ask high-level questions, they enable divergent student responses. You might want to ask, what are some examples of high-level questions? Now, what is high-level questions? So the focus on education has shifted from students being able to record information to a deep, more reflective type of thinking. High-level questions ask students to be metacognitive or think about their own thinking. High-level questions require students to take what they know and apply it in many different ways, such as analyzing, creating, and evaluating. A high-level math question often has more than one question, such as, which question is the most challenging to you? Students using high-level math thinking usually are asked to synthesize or put together several operations. High-level math thinking represents problems that can be solved in many different ways. Often, a high-level question creates a spark of interest from students, making them want to further explore. Therefore, this is so important in our classroom. We want students who don't just want to take in all the knowledge and content from the teachers. They want to explore on their own. They want to discover knowledge on their own. So high-level maths questions are challenging, but yet they are engaging. They stimulate communication within the classroom. So questions should be designed to increase the level of automaticity in our classroom so that students begin questioning each other, themselves, and teachers, and the mathematics presenting. Students should not just take the mathematics that teachers present in the class as the correct and the only way. Students should be able to question this mathematics that is presented in the classroom to make sure they are understanding the concepts that is being taught. Menda suggests that when students engage in questioning each other and provide rationale for their own thinking, they demonstrate a high level of understanding of mathematics. And that's what we want in our classroom. We want students to demonstrate a high level of understanding. So, what are some good examples of good questioning? These are adopted from course in 2005. Some of the samples, she said, that teachers can ask. Can anyone restate what another student is trying to say? I think I know what you are trying to say. Can you think of another way of saying it? Do you agree with a student's reasoning? Did anyone get another answer? Did anyone do the problem another way? These are some of the questions that we should ask in our classroom to stimulate thinking, to stimulate conversation, to push our students beyond just getting the answer, to make sure that students are understanding the concept fully. So we move on. Teachers should be purposeful in selecting problems. They should choose problems that can be solved multiple ways. Why? Because we don't want to leave any child behind. We want to make sure that every child in our classroom have the opportunity to enter a problem, the opportunity to learn. So when we choose problems that can be solved in multiple ways, we have students who are considered to be very weak in mathematics being able to enter this problem, being able to start this problem, and this is encouraging to them. And we also have problems that students who are very strong being able to enter the problem and also feel challenged. It is not too easy for them. So, Drake et al. explain that while teachers are often expected to use a particular mathematics curriculum series, we know that we have to follow the syllabuses and our curriculums from the different countries that we are part of. The question that a teacher should ask should be able to build on and connect to students' multiple mathematical knowledge bases, which is abbreviated as MMKB. So children's MMKB includes children's mathematical thinking and children's home and community-based mathematical fund of knowledge. As teachers, we cannot expect that all the knowledge comes from us. Students come to our classroom from diverse backgrounds and they bring with them different knowledge. So we have to tap into those knowledge that students also bring to the classroom so that they can share with other students and other students can learn from them. And as teachers, we ourselves can learn from students from the different knowledge they bring to us in the classroom. MMKB is supported by an open strategy sharing because it includes multiple strategies to solve problems as well as clears up common confusions or misconception about mathematics. When students are sharing, we get to identify those misconceptions that they may have developed from as young as kindergarten. And these misconceptions follow them right through, sometimes up to the high school level. So when we allow students to share in the classroom, as teachers, we get to identify these misconceptions and we can correct them. And we can alter these misconceptions and students can now develop a better understanding of the given concept that is being taught. The practice of students justifying their own solution and the ability to compare and contrast their solution to math problem will deepen students' mathematical understanding. So students now can apply knowledge that was gained to other areas in mathematics. So students not only in mathematics, but they can apply their knowledge to different content areas like physics, chemistry, and those other science, IT, those other areas, because they are now better able to understand the maths. As they discuss, as they taught the mathematics, they can understand it fully and make those applications to other areas in the curriculum. Another strategy to foster communication within our classroom is open strategy sharing for students. When students have the opportunity to show or explain their mathematical thinking, it reveals both understanding and misconceptions. Also, they feel more important in the classroom. They feel more part of the class because whatever they have to say is very important to the teacher. They are now allowed to share in the classroom. The teacher is no longer giving them all the information or all the knowledge. They are having the opportunity to share, to explain their thoughts and develop further understanding. Therefore, it is vital that teachers become skilled in questioning because the questioning is what will enable our students to discuss, to share. If we don't question properly, we won't get our students to think deeply. So our question should go beyond the knowledge base, should go beyond just reciting an answer. We have to question in such a way that we get students to justify, to make connections. We get to understand what students are really thinking, what they are understanding. And next, selecting good mathematics tasks. This is vital in stimulating communication. The task should be rich, should be a task where students can discuss, not a task where they have to sit and just write down a problem and solve it. immediately. It should be tasks where they have to depend on another student's idea. They have to look at all the different strategies to solve. So learning to think in a mathematical way is cultivated by the mathematical tasks students encounter. And this is so important. As teachers, we must choose tasks that allow our students to think. A rich mathematical task is viewed as a worthwhile task because of the high level of cognitive demand it elicits and the close relationship between procedure and conceptual understanding is cultivated. McDougall defines a rich task as one encompassing a set of attributes that are grounded in the real world problem. One of the problems with mathematics that we can note is that students don't see the purpose of it. Sometimes students will tell you, oh, I don't need this maths later on in life. Why should I be learning some sort of content that I don't need later on? So, as teachers, we have to make the mathematics real to students. We have to allow our students to connect the maths to real world, to real life situations. Therefore, the tasks that we give them should be tasks that apply to the real world. We shouldn't be only giving them computational tasks. We should be giving our students tasks that they can solve a real world problem. And that's a good task. That's a task that will stimulate and foster communication in the classroom. Tasks should allow for multiple solutions, not only one solution. It should also provide opportunities for engagement with many solution strategies developed by students themselves. So as teachers, we are not responsible to give students all the strategies to solve a problem. We should allow students to come up with their own strategy. And this can only happen when we choose appropriate tasks that will allow students to come up with their own strategy, allow students to think through the problem and find different ways in solving these problems. These tasks should involve a variety of representation. Students can represent their solution using a table. They can represent their solution graphically. They can represent their solution using an equation. They can represent their solution using a proof. So when we are selecting tasks that will stimulate communication, it should have many different representations. The possibility of presenting these tasks in many different ways should exist so that students can share their representation and they can learn from each other. Leading students towards making connection between mathematical ideas. So these tasks should allow students to make connection to their prior knowledge, make connection to other areas in the curriculum, make connection to other concepts in mathematics. So our task should be rich, engaging to stimulate this discussion within our classrooms. The task should expecting students to communicate their reasoning. So we have to choose tasks that students can share, can justify their solutions in the classroom. Also, a task that assign continuous reflection, tasks that students have the opportunity to reflect on. And this is an example of a very rich task. If you look at it, we see it's a real life situation. It's something that our students can relate to. Last Sunday, an accident caused a traffic jam, 12 miles long on a 2-lane motorway. How many cars do you think go in the traffic jam? Explain your thinking and show all your calculation. Write down any assumption you make. Number 2, when the accident was cleared, the car drove away from the Front one car every 2 seconds. Estimate how long it took before the last car moved. This is a rich task. One, because it connects to everyday situation that students can relate to. Any child can enter this problem. It provides for multiple solutions in multiple representation, multiple strategies of solving the problem. So this is an example of a rich task that can be used in our classrooms. Another step, we should allow students to justify their solutions within the classroom. Students who cannot effectively explain the meaning of and justify the use of mathematical symbols, concepts, and operations are not yet fully fledged members of the community of discourse. We know we have some students, they will tell us, I am doing this problem this way because my teacher told me this is how to do it. Students do not know why they are solving the problem the way they are solving it. Because we as teachers sometimes we don't force them to justify the reasoning behind solving the problem. So when we ask students to justify the reason, students will say, I know my answer is correct, because they can give the reason why their answer is correct. When we ask questions such as, how did you did this problem? Students can answer. Students will say, oh, I know a different way of solving this problem when another student presents that same solution. Or we can have students say, I hear you say that, but this is my thinking on it. So we should allow students to justify solution. Let them tell us why. Why are you solving it this way? Furthermore, in justification of solution, we have when students are encouraged to justify their solution in mathematics, they are given the opportunity to develop and demonstrate their understanding of important mathematics. And that is what we want in our students. We want our students to develop and demonstrate their understanding of any given concept that we are teaching at the moment. As students explain their mathematical understanding, they learn to think mathematically, and teachers can determine students' mathematical growth on a given concept. We don't have to wait until the end of the term or until the end of a week or until the end of a unit to know that our students understand a concept. As students are able to justify their reasoning, we can tell if our students are growing, if they are understanding, and we can adjust our teaching. If it means changing the strategies, this can happen for our students when we allow them to justify their solutions in the classroom. And we have a very important step that we have to allow when fostering communication in the classroom, making mathematical connections. Making maths meaningful, helping students make connections can make a significant impact in their ability to apply knowledge in a multitude of ways. The excitement and curiosity from meaningful mathematics can fuel the mind of the students beyond anything they could possibly think or thought. So we are going to look at this table. What are some connections that can be made? We have maths to world. In our teaching, we must connect the mathematics to the world. So maths to world connection helps students identify real world application of the mathematics they are studying in the classroom at the very moment. Students would consider the bigger ideas in the mathematics and see how mathematics relate to other subject areas such as science, English, social studies, etc., IT. So that's the maths to world connection. There is also maths to maths connection that must happen in the classroom via communication. Maths to maths connection have students thinking about how the strands or the courses or the different concepts within the mathematics itself are related, how problems or situations are similar, and how connections can also help them understand how concepts and procedures are related. And there is also maths to self connection. Maths to self connection gives students the opportunity to make personal connections, apply prior knowledge and experiences to new problems or solutions or situations. So, we in stimulating communication within our classrooms, we have to allow our students to make mathematical connection to the world, connection to other maths areas, and connection to self. When we make these mathematical connections, this promotes effective communication in the mathematics classroom. Let me read that again. Promoting effective communication in the mathematics classroom is providing experiences that will enable students to make connection among mathematical ideas. When students share their mathematical ideas during problem-solving solutions and engage in reflection, they notice links to current and prior mathematical concepts. By making and observing mathematical connections, students discover new knowledge and real-life applications are eliminated. Students get to see, hey, this math is not just some figures or some letters on the board. This math is real. This math is what we are living. This is what we are experiencing every day when they are able to make these connections. And also, just to add, students get to see how algebra and geometry is connected. So when we're looking at mathematics connection, when we are teaching and we encourage communication in the classroom, students are able to see that, hey, this algebraic expression can be represented in a geometric form. For example, we see Pythagoras theorem. Pythagoras theorem is a geometric concept, but it can be represented algebraically. And similarly, solving simultaneous equation, students can make the connection that this algebraic expression can be represented and solved graphically. So it's so important that we choose tasks that allow our students to communicate the multiple strategies in mathematics and the multiple representations so that they can make this vital connection in the mathematics classroom. So we are coming to the end of our presentation, and the question is, what does effective communication looks like in the classroom? So if you're wondering, am I as a teacher engaged in effective communication? Here are some points that you can ponder on and answer for yourself. Students and teachers acknowledge and discuss errors and the reasons behind them so that students build greater understanding. So the question is, are you discussing errors? Are you allowing both yourself and students to discuss and communicate the reason behind their understanding or their solutions? Students question each other using mathematics arguments to establish the correctness of solution. Can we truly say that in our class or when I'm teaching mathematics, my students are questioning each other using mathematical arguments in order to determine whether their solutions are correct? This is what effective communication looks like in the classroom. Students reach and justify conclusions based on their own mathematics knowledge without relying on the authority of teachers. Students engage in productive struggle with appropriate scaffolds and support from the teachers. Gone are the days when teachers dominate what happens in the classroom, especially in mathematics. Mathematics has been a sore spot for many years. Therefore, we have to change the way we are teaching. We have to allow communication, effective communication within our maths classroom. We have to allow students to justify their reasoning, to make connections. We have to choose those tasks that can stimulate that sort of conversation in our classrooms. And we have to make sure that the questions that we ask stimulate communication, stimulate thinking, cause students to think about their own thinking. Communication is a must in the math classroom. We need to foster the communication. A quiet classroom does not support learning. When students are engaged and discussing, you have more learning happening within the classroom, more understanding being developed within the classroom. I thank you so much for tuning in to this session, and I hope it was very rewarding for you. Thank you.
Thank you, Samantha, for interesting and a very important presentation on how to foster communication in the mathematics classroom. At this point, we open the floor for comments and questions from the participants. And while we wait for them to type them down on the chat, I would like to thank once again the participation of our Teachers of the Americas in this webinar, and also for those ones that registered but were not able to attend. We have recorded this presentation and we will make it available on our YouTube channel at www.youtube.com/ITEN, and also on our virtual community of practice at the link that you see on the screen. We will also have available the materials used in this presentation, including the synopsis and also this PowerPoint presentation prepared by Professor Samantha Porter. So Samantha, I saw in the chat that Sandra Thomas from Grenada commented that she thinks one of the greatest challenges our students face is connecting mathematics to real life situations. Do you agree with this?
Well, that is true. And why students face a challenge is it goes right back to the teacher in terms of how we introduce mathematics to our students. When we are teaching mathematics, as teachers, we should look for every opportunity to bring in our real life experiences into the classroom, to create problems that will support what's happening in the real world, that students can see and make that connection. So, really and truly, we have to really change the way in which we are teaching mathematics. We can't go in and just write computational problems on the board anymore. We have to turn those computational problems into worded problems that will give students more meaning to real life situations. I hope that's
Thank you, Samantha.
That questions or
While we
comments.
wait for other questions and comments, I wanted to ask you about your own experience with parents, with principals, with directors, and other actors of the educational community in order to foster these skills, these communicational skills in the mathematics classroom. Could you please touch on what's the role of these actors in developing these skills?
Well, I think for in terms of the educational officials and principals, they can change the way in which mathematics is being taught and develop, foster communications within the classroom. One of the sore points that teachers will always lament and say is that, oh, we have to follow this curriculum because students are tested on the curriculum. So one, and therefore they cannot have too much communication in the classroom because allowing students to communicate means taking away time from completing the syllabus or the curriculum. So I'm thinking that if the ministry officials or those persons in authority change the curriculum somewhat, so rather than covering a lot of topics, we cover fewer topics, that when the students have covered those topics, we know that they fully understand these topics. And in doing that, it will allow teachers more time in the classroom to have students discussing and sharing, justifying, making connections, and all those things. And as the principal too, sometimes as principal, even though we are given a curriculum, that does not mean we have to follow the curriculum wholesale as it is. We can make changes within our classroom, especially in those lower grades or at high school and even at the primary level. We can make some changes because we know that when they are at grade 6 and when they are at grade 11 or something like that, they are preparing for external exams. But in the lower grades, as principals, we can take a stand or make a decision where we decide this is how we want maths to be taught. We want to see communication in the classroom. Stop focusing too much on completing the curriculum and getting the students to learn all this knowledge. Rather, we should try to aim to have mastery. So we know for sure when the students finish algebra, the students fully understand or understood the concepts that is under the broad topic algebra. Our students can fully explain and explain their understanding of the different concepts. And as teachers, we can do little changes within our classrooms as well. We can decide, all right, I'm no longer going to put just figures on the board or just computational problems on the board. I'm going to try and make every class somehow relate to real life situations so that I can have discussions, I can have more problem solving in my classroom rather than lecturing all the time. In that way, when we have more problem solving, students are given the opportunity to express their ideas and solve problems and communicate within the classroom. And the role of the teacher changes. The teacher is now not only seen as the giver of knowledge, but the teacher will be seen as the facilitator of knowledge in the classroom. So they are also relying on the students to express their thoughts. And everybody in the classroom in that sense can learn from each other.
Thank you, Samantha, for your answers. I see that we have reached the time for this session. However, our participants have posted a lot of questions and comments on the chat. So I'm gonna choose just 2 of them for you to answer, and then I encourage the participants to continue the dialogue on our virtual community of practice on the link that you see on the screen, so you can address these comments and these questions and continue nurturing your knowledge on this topic. So Samantha, the 2 last interventions, one is by Shakania Small. She asks, my class sessions are short as 30 minutes. Would it be feasible to use a rich math task as you presented for such session? I ask this if meaningful discussion and open sharing strategy activities are to be done. And the last one is by Diego Borja. How to promote communication in the mathematics class when the teaching is mediated by technological tools?
Okay, so for Shikana, first of all, in terms of the time frame, maybe we can start the task, but the task can be completed in other sessions. Okay, so we shouldn't just look at the 30 minutes. Students can begin the task, especially if you have tasks that are broken up into pieces. So we have part A, part B, part C. So for the first period, the 30 minutes, you can have them working on task A. But the information that they gain from task A might be necessary for the next part of the question, the next class. Okay, so you shouldn't just limit because of time. You might not be able to accomplish as much as you wish, but you can still have rich tasks in your classroom. You just might have to spread it out for an entire week because of the time frame. And the next question, in terms of the technology stimulates communication within the classroom. And I'm going to use an example. For example, GeoGebra. We give students, we can create so many different examples using GeoGebra at one time. And these examples can allow students to see what is changing, what remains constant, and all those things will stimulate communication within the classroom. I think that the use of technology promotes communication within the classroom because I can get so many things done at one time. Let's say, for example, the sine, curve, graph. We can look and see how it is changing by just changing one thing in the equation, by changing a sign. If we change it positive, negative, we are seeing that the graph changes. And we can have rich discussions within our classroom. Students can come up with so many discoveries, so many generalizations in a short period of time by using technology in the classroom. So technology should not hinder communication. If your technology is hindering communication, that means it is not being used properly. It should actually stimulate communication within the classroom.
Many thanks, Samantha, for your answer to these questions and also once again for accepting the invitation to be part of this webinar. I noticed that your image froze on the video, Samantha, so why don't you try turn it off the camera and then turn it on again.
Oh, the webcam. Okay.
Well, it's still frozen. It doesn't matter. It's fine. So I have seen on the chat that participants were asking if the presentation will be available. Yes, it'll be available next week on the link that you see on the chat. And we will also share the synopsis and the video of this webinar. So I see that we have reached the end of this presentation. Thank you so much, Samantha. Thank you so much, teachers and officers from the ministries that participated in this webinar. We hope that you have gained a lot of knowledge on this important topic, and I hope to see you in the next webinar of the Inter-American Teacher Education Network. Have a good afternoon.